online ones. So I would like to welcome you to my presentation about blockchain and healthcare systems with Java focusing on e-prescribing. If you came to the presentation looking for only healthcare, sorry, I made a mistake with the title presentation, but okay. Let's begin with a brief biography of myself. My name is Pedro. I'm from Brazil. I am 23 years old. I have worked in Santander, Brazil, in the cryptography and authentication area. That's where I get a little bit in love with encryption and security issues. I have worked also in Globan, and nowadays I work in Aubay. Here are some of my main skills: Java, Spring, cryptography, cloud, and nowadays I'm a quantum computing enthusiast. So it's a really great topic that I've been learning nowadays. And just to have a little bit intimate presentation, here are some of my hobbies. That is surfing, football. Nowadays I'm really into reading. Here is my GitHub page and my LinkedIn if you want to connect. Let's move on. So here is a little agenda for our presentation. We are going to start by presenting blockchain and its 5 pillars, some important pillars. We're going to talk a little bit about hash and some key concepts. We are going to see a Java application, a little demo explaining a little bit of key exchange, generating the block, validating the block, and some use cases. And to conclude, if we have time, we are going to say a little bit why blockchain, some famous project, and also why Java. And at the end, we are going to open to some questions. Just to explain a little bit, this is a brief explanation, it's a proof of concept, just to explain the basics of the blockchain and to show that it's not that big, huge monster that everyone hears that everyone thinks when hears blockchain. Let's begin if the control works. Okay, so blockchain. What is blockchain? A blockchain is a digital record keeping system that enables transparency and security. What that means, we can keep records, keep data in a secure way and a transparent way. We can see all the data, not obviously the raw data, but we can see the data that is being transferred between sites, but it's equally secure as a database with encryption because everything has the best encryption and the best practices of the market. And one of the key concepts about blockchain is that it doesn't need any centralized authority. So we don't need any bank, we don't need the government to keep the records, and the purpose of the technology that Satoshi Nakamoto, the true inventor, was to give back the data to the user. So no one has your personal data. No one has your CPF from Brazil, for example, or your NIF here from Portugal. They don't have anything that relates to you. And that's really good when talking about personal data. Okay, moving on. The 5 pillars that I want to mention here. The first of all is the consensus mechanism. If we don't have any central authority, how can we grant the integrity of our blockchain? So that's a really great question. And Satoshi Nakamoto back then thought in a way that we use nowadays as proof of work. We're going to talk a little bit later in the presentation. But let's imagine that all of here is inside a network and we want to validate each other's transactions. So I want to transact some amount of money to Thiago, for example, and how would I do that in a valid way? Everyone here would have a copy of our blockchain and all the records from transactions, and 51% of our network need to agree on the transaction. So if I try to Remember, we are talking about digital transactions. So, for example, I have a file and I want to send it to him. So what keeps me from sending to him, to you, to everyone here in this room? Everyone have a copy of the transactions of that file. And when I send to for example, Thiago, everyone here can see that, and everyone here can see the history of the transactions, and say, oh, Pedro already have transaction that block, or Pedro block, no, sorry, transaction, or coin or value. Pedro have already transaction that value, so it's not valid. Or we can all agree, or just 51% of the network can agree that I haven't spent that money, so I can send to him. We have two most famous consensus mechanisms nowadays. We have the proof of work, that is also known as mining, present, for example, in Bitcoin, and we have proof of stake present on the Ethereum network. The second pillar is decentralization. As I said, we don't need a centralized authority to grant the validness of our block or our chain. Third one is security. So as I said, blockchain uses the best practice and the best encryption and signing algorithms in the market. At least we need to use them, or the companies who work with blockchain must or should use the best practices. The fourth pillar is the transparency. So when talking about transferring money, we don't actually want to, everyone knows how much money I have. But if we need to validate the transaction, we need to know what's happening, because if I want to transfer, for example, 1 trillion Bitcoins and it doesn't even exist 1 trillion Bitcoins, we are going to agree that the transaction is invalid. And that's why transparency is crucial for the blockchain. And the last pillar, and for me the most crucial one, is immutability. So once the block is validated, it cannot and it will not be deleted or altered because of a concept about hash. And what is, sorry. Here's an image taken from Veildan, also in a great article. The link is here if anyone wants to look at it. The Teams is covering, but it's from Veildan. You can search for blockchain Java. Here's an example of a simple example of a block. We have the transaction, the data. It can be a prescription, it can be the amount or whatever. We have a timestamp of the block. We have a nonce, that is an incremental value. We are going to talk a little bit later in the demo. We have the previous hash, and we have the block current hash. We've said a lot about hash, but I never explained what is a hash. I will just get in the top of this topic because it's really, really deep. But a hash function is a mathematical algorithm that takes any size input and transform into a fixed length output. So if you have a file, if you have a simple string, if you have a name, if you have an account, everything that takes into the mathematical algorithm, it will output a fixed length size. And it's crucial for a lot of data integrity. For example, password storage. Whenever you register yourself to any website or you create any account, the database of that company cannot store your raw data, your raw password, because if the company suffers from any data breach, your password will be exposed. So they apply a hash function on top of your password and store the hash. Also in digital signatures. So for example, if you download an executable from a website, they also let available a hash, so you can calculate from that file to see if it's not corrupted or have any viruses. The four key topics about hash is, the first one is one-way cipher. When we are talking about cipher, you always think of encryption, that you have a key that can cipher and decipher your data. Hash is a little bit different. It's very easy to calculate this cipher output, that is the hash, but it's practically impossible to go the reverse way. Why practically inverse? And computation everything can be reversed, but it would take a lot of time. The second topic is collision free. It's highly improbable, but not impossible, to have two inputs become the same output hash. For example, in SHA-1, we already have collision, but at least when I was doing this presentation, SHA-2 and SHA-3 does not have collision. So they are still collision free. To give an example, if you have string and whatever other input, it will not give the same output. It doesn't matter the size. Hashes are deterministic, so it doesn't matter how many times you apply the same hash function with the same algorithm to the same input, it will always give you the same output. And the last one, and a very crucial one, is the avalanche effect. It doesn't matter how small the changes are in your input, it will completely generate a different output. So just to give an example here, we have the first one is string, all lowercase. It will produce a hash of beginning 2757 and the end is 68887. And the second one is a string only with the first S as uppercase. It will produce a beginning of 2373 and the ending of FC3A. If you compare the whole algorithm, the whole output, of course, it will have some characters matching, but it's really, really different. I don't know if the people in the back can see, but it's really different. So why this presentation is in Java? So we have a lot of libraries that is compatible with blockchain technology. For example, Hyperledger, Bitcoin.j, Web3j, and we also have famous cryptographic libraries as Bouncy Castle. But most of all, it's because it's my main skill, and I've already had the project because it's a project that I really like because I made the cryptographic library for that, and I really enjoy working that with Java. Okay, so before we get to the demo, we need to understand a little bit, just to contextualize a little bit of our application. Is a e-prescribing service. Remembering it's not available for market. I'm not trying to sell this project. It's just a proof of concept. We have a mobile application that will be available to the doctor and the patient, and we have a server-side application based with Spring Boot. The mobile one, it's just to the security issues, the key exchange, the ciphering, the signing, the validations, and the server side is the blockchain, and I also included the mining just to demonstrate and for us to understand. So before we get into the demo, I want to just scratch some topics here. We are going to use asymmetric cryptography because we need a private and a public key to expose our data, because we need something to relate to ourselves, but not relating to ourselves. And we need these two algorithms, the encryption one to guarantee our data confidentiality, and our signing algorithm to ensure data integrity. So just for example, here we are going to see a really simple example in a practical one about encryption on our left and signing on our right. If Bob wants to send a message to Alice, he will need Alice's public key, that is public, she can share, to encrypt the message that in this case is hello Alice. He will send the ciphered message to Alice, and Alice, with her private key that she must not share, can decrypt and read this deciphered message. And for the signing algorithm, it's a little bit different because we are going to uh, do the opposite side. Alice wants to send something to Bob, but she wants to make sure that it's truly her that is sending. So she have a document, or in this case, a message. She will use her private key that she must not share to sign it. And once Bob gets the file or the message, he can ask for Alice public key, or she can share, I don't know, in any website or any database, her public key so he can verify. So this is a really simple concept of ciphering. We need to use the public key to cipher, and the private and the signing algorithm, we need to use the private key to sign it. This is just a simple example of the application. There are many implementations of this. You can use, for this example, I use Java, and I save the files in my directory, but you can use any application that can generate key pairs, ECC, elliptic curves key pairs. So for this example, I'm saving on my directory, my computer directory. To create the prescription, we are going to use Postman here. There are many implementations, as I said. We can scan the doctor can scan the public key with a QR code. They can send an SMS. We can send an email asking for the public key. Of course, the public key is public, and we can use it to share to the doctor, for example. But here, just for example, the doctor already have the patient public key. He's going to call the endpoint / doctor with the patient key. He will post the medication. Here, for example, it's just medication, and the expiration dates for that medication. Once it arrives the mobile application of the doctor, he will encrypt the medication with the patient key, and then sign the whole block with his private key. He uses the patient key to sign it because only the patient will decipher the medication to use it in the pharmacy or the hospital or wherever he likes. Okay, so let's get to the demo. Hope this works, but okay. As I said, it's just a simple example. I'm using a array list to represent the blockchain, but we can use a lot of different implementations. This, as I said, is just a proof of concept, and it's very simple, and I don't want to sell this project. So if you want to, you need to implement best and secure ways. But okay, so here we need to create a block using patient key and the medication. Once we created the block, here is the medication ciphered with the patient public key, the patient key, because we are going to use that to retrieve our medications, the doctor key to the pharmacist or the hospital or the medical entity to validate that block, the creation date, the expiration date, and the signature of the block. Here, we're going to post that prescription to the chain. But once it's posted, it cannot be used yet. Here is just the Genesis block. I will get into it a little bit further, but we are not seeing the patient prescription yet because we need to mine it. We need to validate that. And to validate that, we need to calculate hash. But first, I'm going to just explain a little concept about mining. For example, in proof of work, we are going to calculate the hash a lot of times to find a certain number of zeros on the left of the hash using the data of the input. But as I said, hashes are deterministic. So doesn't matter how many times we calculate the hash of the same block, it will always give the same output. So how do we do it? That's why we have a nonce here. That is a incremental number, so we can increment that number and calculate a different hash of each iteration. Okay, let's get going. Let's try to mine it. So just as a demonstration here, I said here. So it took us 512 iterations to find this hash with 2 zeros on the left, with our difficulty as 2. And just as demonstration, I said to each block increment our difficulty just to we know how difficult it is to mine a block. And just for curiosity, Bitcoin nowadays uses 17 zeros, I guess, on the left, if I'm not wrong. And it will get exponentially harder for each difficulty. Let's try to mine it once again. Now it took 7,304, but let me explain my point, adding some more blocks. Oops. Now it took 34,805, and I guess if my maths are correct, the next one it will take a lot longer. But let me guess the next one. So talk, and here we are with 6 zeros on our left, and yet as you can see, it's taking a lot longer. So 361,006 iterations. And if I keep on going, it would take exponentially more time. And that's how proof of work works. We need to work to find the hash and validate that is right. But we are not expanding our process power of our computer, our electricity, our time, mining blocks in exchange for nothing. So that's why Satoshi Nakamoto also thought about a reward as a compensation. So for each block that you mine, you would get I forgot the name, but a little bit of Bitcoin, an insignificant way of Bitcoin. But just mining these blocks here, we are not getting any Bitcoin, unfortunately. But okay. Yeah, so here we are just calculating the hash with a algorithm SHA-512. We are changing it to a hex hash just to be better to see the hash. That's why here is in hexadecimal. It's easier than 0 and 1s. And here's our blockchain service that, as I told, it has a array list. Okay, so now that we've mined our blocks and we have validated it, how can I assure that is really valid? So if we try to see our blockchain here, we can see a lot of data and a lot of hashes and a lot of characters, because you cannot see any exposure of data, because we still have our connection with our patient, our doctor, but we cannot see which patient it is or which doctor or what is the medication. And that's a concept of transparency. You can see everything that is inside the block, but of course you cannot see any data, any raw data. Okay, so how can I assure that this is valid? As I told you before, the blockchain is immutable. So why is that? Because every block has a link to the previous block. So if you see here, this previous block is the same, this previous hash is the same hash that the previous block. And if I alter anything here in this block, it would change the hash. And once I calculate all hashes in the blockchain, it will invalidate the next block. And as I told you before, again, hash function is really fast to calculate it. It's really difficult to find the correct zeros, sequence of zeros on the left, but it's really fast to calculate a hash. So if I try to calculate all hashes from here, if anyone doesn't match, I would invalidate this block. And also we can make a lot of implementations to auditory and a lot of things to keep and to ensure the data integrity. But as a proof of concept, I haven't done it yet. Okay, now we have our patient key and we want to see our medication. Once more, there are a lot of implementations for this. You can show your QR code in the pharmacy. They can scan your public key and show a lot of prescriptions. So this is what we get after we try to retrieve our medications. Our medicine, that is ciphered, and a signature of the block. Okay, if you go to the pharmacy and show this medicine here, this medication, she will not give anything to you because it's not deciphered. So who can decipher this? Only the brother of the one that ciphered. With the public key, we have also a private key. Sorry, if there is any question about private and public key, just ask me there. It's a really deep and a really confusing topic, but as we said here, when we are creating the prescription, we send our doctor our public key and he cipher it with this public key. And we keep to ourselves our private key to decipher this medication. And if we try to use our verification method, sending our medicine cipher, this of course would be in my phone, so I will not send my private key to anyone. It would retrieve us the medication or the medicine, and it would return if it's true or not. If I try to send another cipher, or if I try to decipher with another key that is not the pair of my public one, it would return false and invalid medication or invalid cipher. All right. I'm a little bit out of time, but okay. Moving back to the presentation. So this is just an example of the code of the mobile application. You would send the cipher, the medicine cipher. It would decode your private key from your mobile or whatever you are storing it. It can also be a code wallet or something like that. It has a lot of implementations. Decrypt it, and return the plain text. Okay, so what is our conclusion about that? Blockchain is not, it is a great topic and it's been more important over the years. It's really, it can be really secure. It's really important to give back the user's authority to its data. So you are not exposing your data to everyone, like your document number or something like that. And here, as you can see, we don't need that. We just need a key pair to identify ourselves. Of course, there are a lot of things of parts missing in this project as a validation of the sign, how to exchange the keys with your doctor, but that doesn't really matter because there are infinite ways to implement that. But okay, what is a big challenge of blockchain? I would say that scalability is a really great challenge because when you are seeing a big blockchain that has a lot of blocks and each block is crucial to its validation, you need to scale the whole thing and not only chunks of it. And I see that as a challenge because we need to have a lot of processing power to mine it. We need to have a lot of storage to keep the data. We also need a complement database to have the auditory. I don't know if that's a correct word, but okay. And I see Java as a great partnership to blockchain because it has great capability. It has a diversity of libraries that can work together, and also have really great support from our community, as we can see in JUG. And some famous projects, just to end the presentation, we have Bitcoin, of course, that is for the financial and cryptocurrency. We have IBM Fruit Trust, that is a logistical blockchain. And we also have Medical Chain that I discovered a few days ago when doing this presentation that implements practically the same thing that I'm showing you here. So it's really great, and if you want to learn more, it's just to go Google it. And thank you. Let's get to the questions. All right. I'm shy. Okay. Of course, Jack. Please.
I have one question. Related with your short release, that you can save all the chains in a release.
Yeah.
But how about Bitcoin? Where is it saved?
That's a really great question. I didn't make my research about it because I was not going too deep into that concept, but it's a really great question. I don't know, but I think it has a lot of good implementations like Mongo as well, because we're going to talk about hashing indexes. So it's a really fast way to find it. It's also related with hashes, so I don't know why not, but really great question. What to do with it? Please.
Okay. You can address that already a little bit in the end, but just to gauge thought, is that I was thinking that exactly the scalability problem, because what's the case if you add a new block to every new transaction, at least thinking in the case of Bitcoin, how is that going to be working? If it's going to be increasingly harder and increasingly less economically feasible to mine those blocks.
Okay,
So the
yeah,
things
it's
so
the Bitcoin, for example, it does not increment for each block. It increments 1 0 because it would took only, for this example, 128 blocks to have the full size of a hash. I don't know exactly, but in Satoshi Nakamoto's paper, he has a brief explanation on how he calculates the difficulty. It's based on a large amount of blocks. It would increment a little bit. Yeah. So if like mine 1,000 blocks, it would increment 0,01, for example. Of course. Yeah. But okay, great question. Okay.
Yeah, from my understanding of Bitcoin and stuff like that, and blockchain in general, once we have all the coin generated, basically there's no point of mining it, right? Because you will just be mining without a return of the reward from the mining. So in the end, even if the mining process would be extremely hard, will not be rewarding for the person that is mining. So it's something that blocking the chain won't be feasible, let's say.
Yeah. So great topic is we don't mine just to discover new Bitcoins. We also mine to make transactions. So if I'm trying to transact to you, I'm rewarded with a little bit of Bitcoin, but I need to expand that Bitcoin as well.
Yeah.
So I'm going to transfer to another one, and you can mine it. So it's I guess it's a self evaluated environment. It will always be mining itself to transact that Bitcoin that is already generated inside the network.
Yeah, but in the limit, basically, you would, if I want to give you some Bitcoin, I will be paying at the transaction.
Yes.
So
yeah, it will get like
We'll get to that.
In the end of Bitcoin, for example, it would not be sustainable to transact if I'm paying a little bit of hash of Bitcoin. But that's why Bitcoin increases and decreases its value, because if I'm getting a little bit more of your transaction, it will be more value.
Yeah.
And it will take a lot more of power of my computer. So I need to expand that money to pay my bills, and I'm rewarded with some Bitcoins. I don't know if I answered correctly.
Basically, there's no answer.
Basically, we have a problem to the end of the Bitcoin, but it's really far away from us. Because if we are talking about, for example, the difficulty of finding zeros on the left, it will get to an end because we have a fixed length of a hash, and if we surpass that number of characters in zeros, we cannot just, let's just increment our algorithm of hash, because it would invalidate all the other blocks. So we still have an end, but imagining that we already take 10 minutes, for example, with a machine that can calculate 120 terahashes by second, with 17 zeros on the left. Imagine with 50 zeros. Imagine with 100 zeros. Imagine with, I don't know, 200 zeros. It's really far away from us.
Yeah, but for instance, here in Portugal, it's not rewarding to mine because of the price of the electricity. The compensation it's not enough. So
that's why we have like it's not common to see us as normal people mining Bitcoin. It's centralized in big companies that have like a station in Russia, for example. They don't pay for cooling systems, so they can decrease their bills for of the Bitcoin mining. So we cannot be rewarded anymore, unfortunately. But that's it. Thanks. Great question. Sorry about that.
The Java libraries that we're using for this.
Sorry?
The libraries in Java that we're using for this.
So for this presentation, I built my own Java cryptographic just to learn, but it's also available in my GitHub if you want.
But you mentioned some libraries in Java.
Oh, okay. It was Bitcoin J, Hyperledger, Web4j, and for cryptography issues, you can search for Bouncy Castle.
Because mostly, for instance, it's used in another totally different language like Solidity, right? For writing contracts.
For sure.
For Ethereum, for instance. So I don't see much things related to Java on this blockchain one.
Perfect. As I mentioned, this is just a proof of concept. We don't want to reinvent the wheel, if I know what I mean. But there are a lot of libraries that already implement the blockchain, already implement the security. But if you want to learn the true concepts behind the blockchain, you need to deep down, to go a little bit deeper. You need to implement just with an array list to get the concepts. It's a really great way to understand it. But for sure. Anyone?
Okay. I have a question. I don't know if you said it in the start, so
Please.
sorry.
No problem.
But the question is, all of these topics are related, because you said that this is being used with Red Hat system. So which kind of problem it aims to solve in your work?
Of course. When you are going to a hospital, for example, what is the main reason? Because you are sick. And what they need to know about you. They think they need to know, I guess, your blood type, your age, because you can have certain diseases about age. They need to know if you have any diseases, but they actually don't need to know like your document number. That's another legal issue. They don't need to know your email, for example. They don't need to keep sending you spam because you never agreed to. So it's a topic, it's a purpose of getting back your ownership of your data. If you want to give them your email, you can sign their lettership. But you don't need to get a medication. You don't need to expose your data. You just need they need to know you. You need to know them. They need to know what prescription to give to, but they don't need actually all your data. I think that's it. I don't know if I answered your question, but there are a lot of implementations, of course, and there are a lot of better ways to show this. But yeah, I think there is. Sorry?
Just an example, there are implementations related to supplements of food, for instance. So you can know a specific food in the supermarket, where it came from since the farm.
Yeah.
So you can trace all the way back.
And also, we have a lot of problems with misprescription. So a doctor prescribed a wrong medication, and we can trace that with the blockchain. So it is a really good concept for that as well. Okay, anyone? Perfect. Please, go ahead.
Thank you. Come back. Let's check back your camera. So, first I needed to warm up myself with, just like the same Portuguese that I said before. Thank you for Abdel. This is the second time he stayed here and just, give us some knowledge. When we started today, the meetup, I was talking about that we already have a QR code for our Discord, and they created for us. Thank you so much. You can enter there. I think most of you know about this meetup through the Aubay. So we can follow us in meetup.com to see when we created a new meetings like that. We will have another one the next month. Usually we make once per month. My name is Paula Santana. I'm an organizer, and today I am made an example that how will be a vulnerable, front of many people that maybe will be judged your English or not. This is a really challenging for me, but the problem is not the content, and the problem is not the talk. The problem is only talking in a language that is not my main language. So I hope that during the presentation, I feel more comfortable if my drugs make it effective, okay? If I fall down, please help me, okay? So I think this is not, a new content for all us. But let's talk about this, why this is so important. You created your code with so passion, and you take care of your baby code, and the one thing that you have a shirt, the only shirt that we have in our life that we are gonna die, but we never think about this, but it's the same like this for developers, we know that in some point the systems will fail. So, but usually when we started, planning and doing design for the system, we never think about this. But we needed to think about this. And why? But first of all, let's step back and understand for the main concepts regarding this. And one of them is about fault, error, and failure. For us, maybe, this is the same thing, but no. And which difference between that? When we talk about fault, it's something that, like we made a mistake, maybe something missing during the development process or design process, and this can be a fail, not only for the developers, we are trying doing our job. Why the judgment power? Yeah, can be a hardware failure, an infrastructure failure that we didn't think about. We don't have a control about this. And this will become in runtime. So when our baby is gonna live, will be a error. So the problem is not the fault and the error. In our case here, the problem that when becomes a failure, because the failure it's gonna when our system doesn't work how it's supposed to work. So this is when this is affected our user. So we needed to understand that we are, during the runtime of our applications, those things will happen. It's, we just needed to understand how to handle with this. And, okay, here we have an example. So we have a customer. This customer was so sad with life. She maybe, made a talk and feel like fear and start to go shopping and try to pay her bills, the shopping, but it doesn't work, okay? And this is the problem because we need the money because, we needed to, we like our salaries, no? Yeah. But the problem is because during the process here, this guy, that guy, maybe missing something during the integration process with the payment provider and don't do the good treatment to handle with the error here. And the problem that is not the error happens. The problem was don't do the treatment for the error. So we expose the error for the user. We didn't, created a fallback, another way to handle with this. Okay. Another concept that usually every time when we talk about the resilience, fault tolerance, or any problem that regard the systems, it's availability and reliability. So why? Because when we talk about fault tolerance, usually will enable availability and reliability. How much we avoid failures, we are, keep our systems work better, the functionalities better. So this has been becoming more trust for our customers, our clients. So how we can handle with this? Which strategies usually we can use? One of them, and most common, it's about replication and redundancy. Who never saw this before? It's part of our day. The first thing that, I don't know if you listen this, if you have only one car with this car will broken, you don't have a car. But if you have two, if one broke, you have another one to use. This is a redundancy and availability and replication. So for this, most of the time we diversify some approaches to handle with components. One approach that, it's like a fashion in our, in the systems now, it's, we ended first, a sync calls. I'm sick, okay, use Kafka. oh, I needed to handle, okay, create a queue for this. Because it's a one approach that is not high, availability for the market now. But we needed to keep in our mind as a developer how to use detection and a recover approach too, and checkpoint and rollback. And the main thing that it's a part of the design of the software, isolation. If someone is mad with you, Thiago, when your wife is mad with you, what you do? You avoid her. This is isolation, guys. Okay? This is isolation. So, but we needed to give a names for the things. Why we needed to follow patterns? Why we needed to give names for the things? The first thing that we needed to, like English, we needed to, use the same language to say the things. I think English it's a good pattern, but sometimes the people don't understand, and I don't think it's because the language. But okay, we'll keep with the patterns in our strategy, and we already have patterns for fault tolerance too. There are a lot of approaches for we handle with some problems. And usually this book, I recommend, I advise to read it, or just, to make a search if I needed to handle with some problem here. Okay, maybe take a search, made a search, okay, or use a ChatGPT, or, to take a resume, or, a compile of the things. You have a 4 groups. One, it's, with focusing detection patterns, because the first thing, how we can get this, how we can know some problems before. We have a patterns to recover and another one to mitigation. Yeah, there's some difference between them. And the last one, it's more about the process, how we can create a process. When we usually when you have a bug, maybe you do a post-mortem for this. This is a pattern, okay? This is one approach that we have in this group of the patterns. Okay, but let's talk about the resilience for day. Okay, resilience for day is an open source and it's a famous library. Who uses this already? Okay, don't do questions, please. Don't do questions, please. Okay, we have a deal here. Okay, this is most of the community contribute for this. So this means that the library will, become more each time with more functionalities, and we have assured that some issues will be solved very fast because many people are contributed for this. And it's really easy to do integration with this library. And how the library implements many patterns, okay? We have a modules in how you can see in how say in the fundo. Okay, behind me. Okay, they're wrong. You understand? Okay. Yeah, we have a circuit break module. Like I can use all the patterns, okay, but I can use a specific pattern, just a separate module, or combine it between them. So we have a rate limiter, book ahead, automatic retry, caching, timeout. And if you use a Fang or Kotlin, we have a specific, enables for using in coroutines in Kotlin and for assign interfaces with Fang. Metrics we already have. we have a dependency to handle with the reactivity modules and integrate with Spring and Micronaut. And there's some specific integrations with like Spring Cloud, replace, I think, Hystrix. Hystrix was the full circuit break for Spring, but they deprecated. Maybe the team was, quite fired, and they replaced for resilience for them. It's free, and we have, I think, for Apache Camel too. Okay, yeah, this is doesn't matter what, it's just like you can to read this is really small, but here I have a resilience Spring Boot 3 dependence, and here Spring Boot started AOP. I will use it. I can implement this library in many different ways. Okay, but I think this is the most easiest. I think this is the easiest way that we can implement it with Spring, Java. I use it mainly for this example, but you can use Agredo too. In this case, I'm not specifying a specific module. I use all the modules in the same time. And for enable annotations, I need to use it together with Spring AOP. Okay? And one of the things we needed to keep in mind that it's about configuration properties. When we use the Spring, the base of the Spring, it's we created beans in Spring through the configuration. So they keep it the same meaning here. We can create all the instance through using a configuration profiles. Okay, let's talk about the retry. The name explains itself, okay? This makes me, there's a lot of immigrants here. Yeah, retry is the same thing that, there are immigration place here in Portugal that calls before set and now aim. Yeah, we try call and solve some problem with him. And you try again because you cannot solve it, and you try again because you cannot solve it, and you try again, and you take help of the God and the universe. But in this case, what we are using retry? Why? The first thing you needed to keep in mind that with errors we can handle in this case, because some errors we cannot recover. Like I call API using the wrong parameter. I can solve this in runtime. What do you think? I don't listen to you.
No.
Why?
Because we were trying the same parameter.
I passed the wrong parameter in the code. The code was compiled. It's not gonna change. I needed to change the code, compile again, and do deploy again for done the error. So it's one error that is not a transient. What is this means transient? Please, you are better than me in English. I know this. So what this means?
Temporary.
Temporary. So if I have a network fail, this can be temporary. If my application is not available, maybe if I try again, this will be available again. So the first thing here we needed to keep in mind to use the retry is who failures I want to know about this, that I can recover and retry again. Okay. And this is the case that, okay, I will have a window okay, that I will wait for retry. And I can retry how many times, it will be necessary for my case. Okay, so let's look for the main configurations here. Can you see my screen? No, are you read here? We have a max attempts. I think the name explains itself. So the max value, we will retry. And wait duration between these retries, okay? And ignore exceptions, because some exceptions doesn't make sense to retry, okay? How I'm doing here? Here, I'm specified that in application properties, resilience for J, retry. And let's go back. Oh, okay. And I have instances. We can have a many beans configured, many instances in the same time with different configurations, okay? So in the top of the method, I will create I use the annotation retry, and we have two parameters in this annotation. One of them is the name, and the name is which instance we are using for this process here. So we keep in mind resilience for J will control, how unity of our code, resilience for J will be, he'll do a control, the method, okay? So I will pick up the method that I will control. In this case, I have a class for client HTTP that I want to retry this method that we call my API, okay? The integration API. And here I put the name application B that I configured before. So the configuration application B, I give this name, okay? I can call pineapple, okay? Whatever. And I will put here fallback method. When you are doing a design of application, you think about fallback. Who thinks in fallback? Don't lie. Be true. Yeah. I fight with PO because I need to think in all the cases. Yes, I fight for fallback. This is a part of my DOD, DRR. Yeah, I don't get the story or feature if I don't know how to handle and how will be the fallback. Yeah, who? Look around. Look around. You don't throw me. You think? Oh, help me in this talk, guys, please. So, yeah, it's too hard to think the errors can be show for us and the ways can be fail, but we needed to start think about this. And how, we will start at fallback. Fallback will happen like in our example, in our configuration, I put max attempts 3. This means that I will retry one time. If fail, I will retry again. If I fail, I will retry again. If I fail, the life there is limited. In this case, 2. So I will call fallback method. Here we have a 2 fall. I don't know if I can make the zoom here. Let me see if this is possible for you see. Can you see here? No? Okay. What there are common between these methods? I don't listen, guys. You are praying? Are you praying? Interaction. The name of this is interaction. Answer me, please.
The access modifiers, the name, the return.
The name, the return time, the exceptions. Okay, I got it. So this is an overload, you know? We have, and if you look here, how can I use this? It's too much technology for me, guys. Okay. Which commons with this method? The method there assign, right? The header of the method. The type return can be the same of the method for fallback in this case. If we received parameters in our method, we needed to receive it in fallback too. The difference that the fallback methods, we received exceptions plus, okay? And we can have an overload for each method for do a treatment return difference for each exception. Like some exceptions I want to, give a default value or maybe do a different operation. Usually, I don't know who works anytime with a gateway, payment gateway. No? Okay. Yeah. It's not about my current job, okay? My coworkers, no, I'm not talking about my current job. It's another one that, made many layoffs that maybe you listen. It's very popular in Portugal. Okay. When we call a gateway for payment, usually they have like, you pay a gateway like we'll call PayPal. If PayPal is not available, you need to call another gateway. Né? This is a fallback. Yeah, if.
Alien, sprinkling, repeat.
Yeah, because you need to have sure that you need to get the money. Doesn't matter what the way of the gateway of the payment, you need to just charge the person and get the money and do the shopping. So in this case, our fallback will have the same return time, the parameters, and just keep this in mind because this is the same pattern, the same module for all the annotations that we have. Retry, it's one of them, but how fallback method works is the same. How we can think about this is the same. Fallback is the most popular approach for fault tolerance. Okay? Okay. So let me go back to presentation. Okay. So now let's talk about the time limiter. I think all of you knows about the timeout. We can, we have a timeout for everything in your life. And no, I think in one example that I'm not doing, I won't give this example now yet. I have a limit for jokes now. Okay. Application A, you call application B. How you can say, I'm so, creative person that I created application C. And if HTTP call HTTP application B, and this is have a limit of the time, I will just block it. Why am I using a time limiter? Why? The question here is, most of the time, timeout is not a new word for you. But why we use a timeout? Why we have to use a time limiter?
to avoid blocking the resource.
To avoid waiting forever.
Some persons like to wait forever, yeah. Yeah, but yeah, this is one thing that can be happened, this is can be happened, but usually there's some limit, you know. If you, we cannot to waiting forever because the machine, there's a limit. The systems, there's a limit because the machine has a limit. So something will be done. The versions will be, you know, done. This is, you know, usually we have this approach to avoid to pass delay between the components. Why we have a distributed system? The first thing to, you know, just to decouple and avoid, you know, to keep problem in you know, isolation. We isolated the problem. If some component there is delay, what we do? We just isolate it. I will avoid that the problem in application B of, I don't know, doesn't matter for application E, what is happened. I just will avoid that this problem will impact this application. In this case, what we needed to keep in mind, one thing that, okay, how I can go ahead with my process here, how I can handle with this too. We back for the you know, the first thing. Will be our fallback. So the configuration is really simple, but one thing we needed to understand. All of you use a client. Can you give a names for me? I am using a web client from Spring. Give me more names. Fangy,
Rest template.
REST template. You are using another one?
Ketor.
Ktor, whatever. We have many clients, okay? All of them, we can put a timeout there. We can put there. If you never use it, but you can. So why I will use this approach? You know, if I already have in my application, in my library. In this case, there's a joke, not a trick, okay? Something that we needed to keep in mind. This is one thing, cancel run feature. Do you know about completable feature in Java? Completable feature, what means? I will get a help for Thiago because I didn't understood this part of my presentation. So help me, Thiago.
Okay, sorry, what do you want to know?
What is completable feature?
It's something in Java that you can use to have async operations. You can have.
Thank you so much. I think this is enough. Thank you for helping me. Okay, so we can have a sync method and async method. So completable feature, it's one of them. I'm using completable feature because in the library, if you read the documentation, official documentation, this is requirement. You cannot use a time limiter annotation in a sync method, okay? If my method just return a string or an object, will fail this annotation, okay? So in this case, this annotation is just for async methods. This is involved Arch Java or a Spring Reactor or completable feature implementations, okay? And why we have this parameter? Because, you know, Collins, give your hands. Oh, okay. Collins is my coworker. He works with me. I will talk a little story now, so example of this, okay? I said, Collins, let's go have a lunch. And Collins usually, you know, always be late. And I have time to go to the restaurant and have a lunch because I will have a meeting. Collins, I have a limit, so my timeout duration expired, okay? So I go to the restaurant. We have two possibilities in this case. The one that I will cancel run feature as a true. In this case, Collins is gonna want to go meet with me in the restaurant, okay? Because I cancel the feature. I have my timeout and I will just give my lunch by myself because I'm not with Collins, okay? But if I keep cancel run feature as a false, this means that Collins will meet with me in the restaurant. So I have my timeout. I go to the restaurant, make my order, but he will get me there. So this is how we can handle in some situations that we have our timeout because we needed to process everything in one call. But the things that we call the second, like we call a database, I will just have assured that the data is there. But, I just, going in and process the other things. In some cases, most of the cases, we are cancel run feature because doesn't make sense. It's a little, like a trick this, okay? So the same thing here. We have a notation with the name time limiter here, okay? You cannot to see, but I'm, spelling T-E-M-E. Okay, do you understand that we have two parameters, name and fallback method? We know how to work fallback method. Can be the same as signature of the main method. The return time can be the same. We can create a different fallbacks with exceptions different, and we can give a exception too. Maybe in this case, I'm true. I will get the exception, and I will throw a new exception, my own exception in my application exception. So I will do a treatment in an error handler. Error handler is so common, and this is a fault tolerance approach too. So the next one is a rate limiter. Who got the subway? The daily, when you go to the Aussie, did you get in the rush time? There is no rate limiter. No. In São Paulo, oh God, how much people, you feel like your body, yeah, because there's no rate limiter. And why we use the rate limiter? Why?
I know video is.
To avoid?
OS.
The DOS, the line of.
Yeah, so many requests. So it's also
If you have too many requests, CPU and the memory can go high and have OMQ and your pause or something like that.
Okay. What the guys are talking here that we needed to, we can use this to avoid a DDoS. When we have a too many requests that the server can, your server, like we use it, Spring Boot. Spring Boot, behind of the Spring Boot, what we have? The server, the HTTP server, usually. In this case, I think the default is a Tomcat. Yeah. Tomcat, there's, a numbers of the threads will be running in the same time. And if we, full this, the DOS will happen. But the problem is not this has happened with one application. The problem, will be happen with the whole components. So this is the main problem that we needed to keep in mind. The problem is not the problem, but it's the whole problem. The problem is not one thing, how can I say, when you feel like a belly, yeah, the problem is when if all of us go to the bathroom at the same time with, a pen, will be the problem, you know what I mean? Okay, in this case, we needed to understand that, okay, we pass through the other application, 10 calls. Okay, and what happened with the red calls? You saw the red calls I put in the drawer? Okay, I will go back. Look for these red ones here, okay. And configuration, we have a 3-man configurations here that, most of these patterns work in a window, like a cycle, okay? And this is a limit for parity. So how many calls can be happen during some window time, okay? And this will be used for height. And keep this in mind. The height limiter uses a height to calculate this limit. Not the number, the total number. It's not, will be for parallelism, okay? For the same time. There's a little bit different because we are talking about another pattern that will be work for this. And this is limit fresh parity that, I put there 2 seconds. It's too much for the real life, we know. Timeout duration. Why is timeout duration? You remember the red calls? The red calls, it's like, okay, like I'm the door here and I will, receive 10 persons. Okay, wait, please, because, this person is doing something there. This is the red call. I'm not doing, I'm not saying for this person, oh, go back, you cannot enter there. No, I just will say, wait some moment. I will see if you have some, some chairs to, bring to here for your seat. But maybe I can see that this chair is not available. So I will go back and say, oh, I'm sorry. I cannot allow to enter that. This is the timeout duration because the cycles has a time. So each time, maybe these calls that are waiting, we can very quite near to refresh the time and get those calls to process. But these calls cannot to be there all the time. So we have a timeout to this. 1 second. If they are more than 1 second, I just say, oh, goodbye, go with God. I cannot handle with you. Okay. And the implementation is the same, okay? Here, we cannot see, but it's annotation rate limiter with the name of the configuration I put in configurations and application properties, okay? In this case, I'm doing the treatment for request not permitted. I'm handled with the same thing, but before the DDoS. And the star of the night. Microservices and .io. If you don't know, you need to know. Okay? It's like a Bible of the microservices. Chris, my friend, no, I never say.
Can you repeat the name?
Microservices.io. Yeah, well, Chris Richards it's a famous person, writer, that, just compile the main patterns many years ago, I think 10 years, 15 years ago, when the microservices started. He compiles the main patterns in this page and created, the main book that we already have for microservices. And one of the patterns is circuit break. You have energy in your house, and maybe you have a control panel. Yeah. And I don't know, this is happening with you sometime, just fall down, the buttons, and you don't have more energy. Yeah, you thank God for this, because maybe you can be fired, your house fired, because the circuit break will detect a failure and just avoid that this failure will be propagated for another components. In your house, maybe your bedroom or something, components, electricians that, it just fired. So this is a state machine that we need to understand how the states works. The three states are closed, open, and half open. Okay? What happens in the closed state? The circuit break it's like a gossip, neighborhood that just look what is happening. Okay? What is happening? The older, neighborhoods that look in the, look in the window and looks that, they are useful if the problems happen, because he looks, it's like circuit breaking closed state. He just looking the calls and keep this information to compile a rate for the failure. Like we said, most of this approach uses a window time, okay? In this case, we have a window time for circuit break, look the calls, and give a hey, error. So if the height will be high, of, we are considered like a half of the transactions will be failed, you needed to just, avoid that this will be propagated for my application. So the circuit breaker will be open. Like, okay, circuit breaker will be just give a fallback. Avoid that you call the application are failed. And half open state happens because circuit breaker cannot open all the time. So there's a limit of the parity. It will be open. After that, half open will work to analyze a little bit of the calls, like, experience, and understand if the things, it's work now, or if maybe keep open, okay? In this case, if we have a call and he take a hate error that, okay, it's everything okay, he will be closed again. Okay, let's talk about the configurations, the main configurations here, okay? Yeah, it's too late. I talk a lot, but, just keep, okay? Stay with me. We are done this. Slide window time. We can choose which approach will be, using for calculate the rate threshold. And we can use it a counted base or a time base. Counted base, he will analyze if you will put in slide window size like 30, the circuit break will analyze 30 calls in the counted base. If we put a time, he will analyze it during like 30 seconds, all the calls, and give a rate of these errors. And the failure rate threshold, it's how much will be considered to circuit break open. So if I put here like 8%, if the height errors will be more than 8%, the state of the circuit break will be open, okay? So we can call together now. How many states we have in circuit break? 3. Close, open, and half open. Close, circuit break, it's just look like the cosby neighbor, okay? Open, he will like avoid that our application will call the application with the problem and just give redirect us for a fallback, okay? And half open, it's 1%, like a little bit of the calls will be used for it analyze again the problems and understand if he will change the state for close and allows the calls for the second application, or if it will keep the open, okay? Permit the number of the calls in a half open state. This it's a number, how many calls we needed to analyze. And the weighted duration in open state, we can, this is, I think this, it's missing here in the table. I think this is 5 configurations, the main 5 configurations for the circuit break. And it's a proposal. I created many applications here in the instances. Okay? Because maybe, if you have application, usually we always have applications like BFF or orchestrator. In this case, we are calling many applications. And we can have a circuit break for each application with different parameters, okay? Here, like we follow the approach, we have annotation with the name circuit break, the name of the instance, and fallback method that I created 2 fallbacks here. One for a web application response exception, because this is an exception I will get when my call fail here. But call not permitted exception is the exception that circuit break will throw when he's in the state open, okay? Open state. So in some cases, I will give an example. Pix in Brazil? Okay, I use a circuit break in Pix in Brazil. And the case was that I was working a fraud flow, okay? When, like MBA, when you are, register yourself in the MBA, you take a number, okay? So maybe there's some analysis that will happen when you register yourself in the MBA. What we are doing in this case is that sometimes we needed to call many, engines for, fraud. But if some engines fail, we assume the fallback for circuit break, if circuit break open for some of the engines. We are assuming just that, okay, we go with the register. If this can be a fraud, we analyze, this is like a risk that you assume, but fallback in this case, like it's approved automatically. Okay? So, and the last one is a book head. Book head, there's some, a confusion between hate linker. And why? Because the both it's for, give a limitation of, research. But in this case, can we imagine that maybe we have 200 points in my application A, okay? But one of these endpoints, are so consumed all the resources that I have in my infrastructure. My JVM, this is a full book. In this case, doesn't make sense because my research one don't have space to answer the client's when clients call the research one, they just give it like a DDoS or, it's not available, the server cannot handle with this. One of who works with Kafka or any consumer listener, some cases we have applications that we needed to keep in the same application, listeners or some, jobs to generate a sync process and HTTP calls. But we needed to split this because, the profile for a job, it's so different. Usually what we do in the job, we keep in the night time to avoid the problems, This is one approach that usually we choose. But we can just, I guarantee that the resource will be available in different profiles that, okay, I have like 100 of the memory. I have 100 in the perfect way, okay? I don't have imagining, so I'm not creative, so I'm backend for this. So let's just follow me. I have 100 of memory, I have 100 of the threads, and I will split this because my listeners require like, okay, take just 20 and, take half with this, make happen with this, you just will use this for process. For the listeners, I just will give like, a 30, and the rest of them will be available for HTTP calls. This is how we can use a bulkhead, okay? To give a specific processor in our application the limit of the resources, okay? And okay, but the hate limiter can, it's so similar. Hate limiter, hate limiter. And it's not about the same resources in the same time. And when we talk about bulkhead, we are talking about the threads and the resources, okay? So I'm missing something, but I didn't remember, but okay. So let's go. Here, what we have, the time of the bulkhead here, okay? So how many times the cycle of the bulkhead will happen? And how many threads? Oh, I remember. I will give you an example for you. A concurrent calls here. Concurrent calls because bulkhead will be handled with threads. So we can specify in bulkhead a thread pool too. So we can use a bulkhead to control pool of threads or individual threads, okay? This is one thing that I think it's not common approach that you can see in any time in applications, like Six to Break will become really popular. But this is, an older approach, I think, that is still happen and useful to control in some cases that required, a specific environment to availability for the components in the same system, okay? And I will give an example. We are just finished. That can we imagine that we have a cafe machine there, okay? But I will separate it like, one machine for old persons, like, more than 70 years, and another one for the, people with less, okay? And the problem, I separated the resources, but, like maybe I have three machines, and one for old persons. But maybe the old persons, I have the same amount of the persons, but how you handle these machines can be different for, for the follow. Just to separate this, maybe the old persons take more time. And, the young persons like, oh, I don't like the sugar, I don't need this, okay, and it will be more fast because it's a different behavior. So we split this in different resources. Okay, and just to show you that about metrics and why we needed to export metrics about those patterns and why this is so important to enable when you use this library in your application. And here, this is really, really easy to integrate with Actuator endpoint. And we can generate to export this data for Prometheus too. And most of the time we can get this, ingest this data to, make the alerts. Can you imagine if your circuit break is open most of the time, there's some problem. It's not only put circuit break, okay, I'm so glad God, fallback exists. So, I'm so excited, I'm the developer. But no, because if the circuit break is still open, in this case of the peaks, when it was a problem for configuration, but we get perceptions that the circuit breaking, the morning doesn't change, it just keep it open. And this wasn't a problem for the circuit break, for our configuration to integrate it with some of one of the machines, the engines we are calling. So we get this because why doesn't change the state of, just keep it open? There's some problem, and we talk with the engine. I think I didn't remember the name, but they do a test with us. Oh, we are available. We didn't receive any call. Why doesn't work? And they give a wrong, credentials for us. So this is one thing that will be nice to get a matrix. We can expose for all those patterns. Here it's a Prometheus, just for you see that we can export in the both ways. And just for review here, we have a patterns. I just talk about some of the patterns. And I think the main point here that why we are using, why we warn with to implementation of those patterns. And the strategies, the main point I make highlights all the time: isolation, and fall back. You can use this strategy for your family, for many resources in your life. This is like a session code here for your life. Yeah. And I just, want to see what your opinion about this content. If you want to bring something and put highlight in this is your time, please. I just needed two. We have a time for 2 highlights here. Who can do this for me?
I think one thing that we will include in this presentation is like explaining that we can do this type of stuff in system in between both, in between the integration, basically like a reverse proxy. Basically, instead of doing in-app all the resiliency stuff, we can do it in case we are calling the integration through HTTP or stuff like that. We could use that externally to our service.
Yeah. I never use it like one of them we can. But circuit break, I don't know if this is usually too external. You already have the users?
You do have some libraries that allow you to create reverse proxies out of the box, like with configuration, and it basically abstracts that from the point of view of your application.
I realized
You
just
just call it, you just call
not,
it.
yeah, just because you can reutilize like a component in your architecture.
Yeah.
Okay, I realize it now. Yeah, yeah. It's important what Andres said that we can just, implement components, just that the main purpose is just to be this is a component that will be failed, but there is a problem in this case. The problem that why we put some approach inside of the code.
It depends.
Just, yeah, it depends. This is one thing that we, it's not because what I mean, there's no right or bad
Yeah.
way. What I see in this case, the good thing that we can decouple and reutilize I can utilize this as a component in many places. Yeah. And I avoid to duplicate rules, but the problem that I cannot to customize too much, in my specific flows, with my business flows.
For the bouquet, for
And the problem, the main problem I see in this approach that the network, most of the problems that we needed to handle is regarding network. How many, and sometimes we needed to do a treatment inside of the code because this.
Yeah.
But it's a good idea. Most of the time, we needed to keep in mind that there's no wrong approach. Just there's a pros and cons. We needed to, maybe like a math to get, navigate what is worth more. And this is my the QR code from the slides. You get access my GitHub with all the examples of the code that include the test cases I use it in JMeter. I export JMeter files for the tests, each scenario. And the about me, they're my profiles. You can find me in Twitter that I didn't use it much, but in the LinkedIn too. Yeah, that's all. Keep follow the JUG. Usually in the end of the meetup, I made it like a competition between the presents for some questions that we had a ranking, and that who wins get or IntelliJ license or some stuff. But today, no, I just want to encourage you. I have IntelliJ license just for the members of the meetup. JNation, do you know the JNation? JNation is, I think it's the biggest conference in Portugal with focus in developers, okay? And this is born with a Java community. So I think it will be in Coimbra, because I don't know if you know, the first JUG grows in Portugal. JUG, if you follow JUGs, there's JUGs around the world. It's a group official for the Java users, okay? And JNation will be, it's really great. I went to there, I made a talk there. It was my first English talk that I met Thiago. Thiago made a question that I didn't know to answer, and I want to kill him, but now we stay friends.
I think I have a question.
Oh, no. Keep in your side, please. So what I want to encourage you, I will I talk with the owner from the JNation, who is principal from Red Hat. I don't know if you know, Red Hat. I don't know if my spelling is right. And I will, maybe do a competition between the persons that if you come today and you keep it coming unto JNation, we have a meetup in April, May, and June, the first days from these 3 months. And I will give, I don't know which, okay, I will have a free ticket, but not for all that will do the trip. But I will make a deal with him to a great discount, and I will sort it, handle these free tickets between these persons, okay? The IntelliJ license, I will give today for Joyce. Joyce come here until the first day, and the second one, I don't know, you get one already.
No, I already have one.
So
Thank you. I don't need.
you already,
Yeah.
okay. I just think from then, you already have two, because they comes until the first day here and stay here with us. And until the first day that we organized this meetup, and this is just to encourage the persons, stay, support us. It's a little bit, difficult to get the persons to make the talk and to give here to share the knowledge. I don't have too much to share, but, I still here to try do this. So you can do this. I explained in the beginning of this meeting that I found my first talk was because I just, want to learn the things. We can, get, I need to study this. This is will encourage us, and will be, it's not, like a motivation talk I'm doing now. It's just for we grow up this community, because technology community doing like that. Andres becomes starting here and he just go and do the Discord because why? Because he wants to get to the Coimbra JUG and try to find some persons to go with him. This is how the community grows and how the things happen. So I do some photos. I don't know if you have some problems with photos or images. I didn't get the your sign. I'm sorry. I will be maybe praised because of this. But can I take a photo with all of you?
Yeah.
Okay, thank you so much for today.